Hello students! In our previous video, we saw that carbon is very useful non-metallic element. It is present in all living things and non-living objects around us in different proportions. In addition, we also learned that carbon exists primarily in its different allotropic forms. Students recall that allotropes of any element are nothing but two or more different atoms of that element combined together in different shapes and sizes which exist in nature. They exist due to the different arrangement of atoms of that particular element. As we know that allotropic forms have the same chemical properties as there is no change in their chemical nature. Since atoms are same, but they have different physical properties as the arrangement of that atoms are different, and hence their shape, size, etc. are also different. So today let us learn about different allotropes of carbon. First of all, let's talk about the crystalline form of carbon, that is the diamond. Diamond is the hardest crystalline form of carbon. In a diamond, each atom of carbon bonds with 4 other carbon atoms and forms a rigid 3D structure. And because of this structure, diamond has a very high melting point of about 4000 Kelvin or more. Diamond is hard and bad conductor of heat and electricity. And do you know why? It is because all the atoms in diamond are bonded tightly, and they do not have free electrons that can conduct electricity. Do you know, students? Diamonds can be synthesized artificially as well. This can be done by taking pure carbon atoms and putting them at extremely high pressures and temperatures. This will result in formation of crystalline structures just like diamonds. These synthetic diamonds are small, but the best part is they cannot be easily distinguished from natural diamonds in terms of shine and their appearance. Diamonds are commonly used as gemstone in jewelry. However, it can also be used for many industrial processes and many other operations. Hardness of diamond makes it extremely useful for drilling, grinding, or even cutting objects. Yes, you heard me right. This instrument that you see on your screen is a diamond knife. It is used to cut glass and drill rocks. Let us now learn about another crystalline form of carbon, which is graphite. In graphite, each carbon is bonded to 3 other carbon atoms. It forms a hexagonal structure in the same plane like this. Now, if you observe, graphite is not rigid like diamond because it is formed by hexagonal structure consisting of several layers. These layers are placed on one onto the other, and they are connected to each other by weak intermolecular forces of attraction. Due to these weak forces, these layers can slide on the top of each other, which makes graphite soft and brittle. Because of this arrangement, movement of free electrons is possible, and thus it is also a good conductor of heat and electricity. You must have seen graphite in your day-to-day life. It is grayish, glossy substance. Its melting point is about 1800 Kelvin. It is used in pencils as lead and lubricants. As it is a good conductor of heat and electricity, it is very useful in electrical appliances like electrodes or electric poles, batteries, and solar panels. Now let us learn about fullerene, which comes from another class of carbon allotrope. Chemically, fullerene is made up of a combination of a larger number of carbon atoms. The first known fullerene molecule is C16, or its name is Buckminster fullerene. The discoverers of C60 named it after Buckminster Fuller, an American architect who used to design geodesic domes. And these geodesic domes looked quite similar to this C60 molecule, and thus they named it after him. Buckminster fullerene or C60 is the most common naturally occurring allotrope amongst all fullerene. Yes, you heard me right. There are many molecules like that of C60, and hence they together form whole family of carbon compounds known as fullerenes. They can be of different shapes and size as you can observe on your screen. They can be either tube-like, spherical, disc-shaped, etc. Can you observe here that C60 is shaped like a soccer ball or a football and thus commonly called as buckyball in short. In C60, many hexagons and pentagons are formed by linking carbon atoms by both single and double bonds. So these are different crystalline forms of carbon in which carbon atoms are arranged in different variety and shapes. Although their physical properties are very different due to their different structures, there are similarities in their chemical properties. In our next video, we will learn more about structure of carbon atom in detail.